This is I'm starting with this video. We are looking at hypothesis testing. So a hypothesis test can be used to decide whether to accept or reject the null hypothesis. And the null hypothesis, which is H0, is a statistical statement that represents the basic assumption. The alternative hypothesis is H1, and this is a statement that contradicts the null hypothesis. So firstly, in this question, we have to state H0 and H1 in each of the following cases. So the first one is the probability of an event occurring is stated as 0.6, but this is thought to be too low. So therefore, in our null hypothesis, which is H0, H0 means that P is going to be equal to something. This is our basic assumption, and in this, P is equal to 0.6. Then H1, in this case, P is going to be, as it's too low, P is going to be more than 0.6. And this is because they think that 0.6 is too low, so this is contradicting it. It's going to say, well, it's going to be more than 0.6. 0.6 is too low, it has to be more. In B, it says that the probability of an event occurring is stated as 0.7, but this is thought to be too high. So this means that H0, so P is thought to be 0.7. That is our basic assumption. But our alternative hypothesis is saying that actually that's too high, so P is going to be less than 0.7. And then finally, in C, it says the probability of an event occurring is stated as 0.4, but this is thought to be inaccurate. So here, H0, again, our basic assumption is that P is equal to 0.4, but H1 is thought to be inaccurate, so that just means that P is not equal to 0.4. Now it's important to show here, this is a two-tailed test, which will come in not useful in this video necessarily, but in future videos on hypothesis testing, this is extremely useful because it will matter about when to accept something and the hypothesis test. Whereas these two, because they're either more than or less than, it's a one-tailed test. So it's important to know that now from the basics that the difference between a two-tailed and a one-tailed test. So the next questions relate to whether we accept or reject the null hypothesis. So the critical region is a set of values that lead you to reject the null hypothesis. The acceptance region is the set of values that lead you to accept the null hypothesis. And the significance level is the percentage of incorrectly rejecting the null hypothesis. So essentially, as the significance level is lowered, you'll need more evidence to reject the null hypothesis, so this lowers the chance of incorrectly rejecting H0. So this question says that James estimates that on 25% of the days in a month, Leeming gets fewer than 4 hours of sunshine. His friend thinks that the percentage of days with fewer than 4 hours of sunshine is lower than that. So the critical value at the 10% significance level is 6. So first of all, as we did in the first part of this video, we need to state the hypothesis needed to investigate this claim. So the hypothesis, H0, is going to be P is equal to 0.25, and then H1 says that P, he thinks that it's going to be less than this, so he's going to say that P is less than 0.25. Now in these sorts of questions, it's also often good to define what P is. So we can say that P is the probability of Leeming getting fewer than 4 hours of sunshine a day. Then for part B, it says if James observes that Li-Ming gets fewer than 4 hours of sunshine on 5 days in a month, state whether you would accept or reject the null hypothesis and state your conclusion. So this is another one which expects you to write a little bit, and we are having to look, so the critical value in this is 6. So it says at the 10% significance level, it is 6. So therefore, we can work out that the critical region, because it's less than, the critical region is when x is equal or less than 6. That is our critical region for this first part of this test. So therefore, if it gets on 5 days, this is in the critical region. So therefore, what we're going to say here is that reject the null hypothesis and the probability, that means that the probability of getting fewer than 4 hours of sunshine a day is less than 0.25. And that is because we're going with the alternative hypothesis instead of the null hypothesis. So then for C, which is the next question, it says that James observes that Li-Ming gets fewer than 4 hours of sunshine on n days, and the conclusion was there is not sufficient evidence at the 10% significance level to say that the percentage of days in a month on which Li-Ming gets fewer than 4 hours of sunshine is less than 25%. In other words, that's essentially saying we accept H0, we accept the fact that the probability is 0.25, unlike in question B where we said that in fact it was lower than 0.25, so we didn't accept H0. So then it says state an inequality for n. So in order for this to be correct, it means that the critical value, which is normally less than or equal to 6, well that means that it's going to have to be x is more than or equal to 7. And that's because if it was any lower, it would be in the critical region and we would reject H0. But in order to accept H0, the x is going to have to be more than or equal to 7. So that is what n is. That is the value of n. So the last question here says that the critical value at the x% significance level is 5. State an inequality for x. So normally x is less than or equal to 6. So if we made it x is less than or equal to 5, that would mean that you would need more evidence to reject H0. That means that it is less likely to reject H0 incorrectly. So therefore, the significance level is normally 10%, but as it is now less likely to reject H0, x is going to be less than 10. So the final question we have is looking again at the idea of inequalities, and it says that our null hypothesis is that probability is equal to 0.2, and then our alternative hypothesis is that probability is not equal to 0.2, so again a two-tailed test in this particular example. So a random sample of 80 is taken, and the critical values at the 5% significance level are 8 and 24. So then find inequalities for A and B, where A and B are the critical values at the 10% significance level, and A is less than B. So we have our two ranges. It's going to be, if at the moment, if it is less than 8, we reject it. And if it is more than 24, we would also reject H0. That is at the 5% significance level. However, if we are at the 10% significance level, that would mean that it is more likely to reject H0. So therefore, we know that A is going to be more than 8, and B is going to be less than 24. That is because it is therefore easier to reject H0. In B, it says find an equality for x if 7 and 26 are the critical values at the x% significance level. So for this example, it's now less likely to incorrectly reject H0, as it is harder now to get the critical value. It's a lower value, so 7 is lower and 26 is higher. That means that X is going to be less than 5, because these were our critical values here, 8 and 24 at the 5%, and because 7 is lower than 8 and 26 is higher than 24, therefore the significance level is going to be lower. So thank you for watching this video, and see you soon. Bye.